Hello, welcome to another PlayBASIC blog. It's the 24th of June 2017. So, the latest things we've been doing have been getting the release build done. So we've got a version of PlayBASIC 1.65b that's on the server for you to download. Finally, you go, oh my god, excruciating. Yep, it's been pretty excruciating for me too, don't worry about that. So what are the differences between 165 and 165b? They are progressions of the same idea. We are starting with 165, we're moving to a new runtime, a new instruction set, and they're static instructions, so it doesn't modify opcodes while it runs, which is a kind of an older secret that you'll find in some of the older runtimes. As for why it does that, well, you can work it out yourself, I'm sure. Not here to give every single idea away. You know, there's got to be some mystery about those things. Okay, so we've got a new instruction set, but in the first revision of 165, got a bit of a cold, as per usual. In the first revision of 165, we moved, a portion of the command set across to executing on its side, but we still had this kind of flip-flopping nature where it would run some stuff on the new side, and then if it didn't understand an instruction, it would just kind of revert back and execute that part on the old runtime, and that wasn't very efficient. So in this new build, we actually have all of the primary command sets are all running on the new runtime. The only exception is the debugger hooks, which I think we talked about last time. They need to be, well, reimagined. It's probably the best way of putting it. And the debugger itself needs a bit of love. Hasn't changed really in 10 years. And it's more of a state monitor, more of a way you can sort of stop the program and just kind of look at, most stuff while the thing is stopped. I mean, it'd be great to take that further, and maybe we will, or maybe we'll just make those things open source and other people can do it for us. I mean, that would make the project much easier to maintain. So anyway, so in 165 we've got some debugger hooks, and I think there's a handful of commands that's still running on the old the old runtime. And it turns out that they're special case kind of instructions, and I was looking at pulling them across, but yeah, it would require a bit of altering how parameters are matched inside the compiler for starters. And I thought, well, if I open that can of worms, I'm going to end up with having to redo a whole bunch of stuff in the declaration tables for how the commands exist. I just couldn't justify for this build. So the ones that are left over are things you might not expect. These are print and text. I think the other one is sync, and that's about the only ones I can think that are actually still running on the legacy side. So when it hits a print statement, it has to jump back to the old VM, run that, and then restart the new VM. That's why that's kind of flip-flopping nature is kind of slow. Even so, all of the benchmarks that I've been running on it, of course, even the first benchmarks on 165 were much quicker than 164. So 165, we're at least running part of the code, part of the logic on the new runtime, and then we're running some stuff. Well, a lot of command set stuff on the old runtime. In this version, we're running 99.9% of it all on the new runtime, and a few things back here. So syncs don't really matter. These aren't really, like, sync is not really a command, it's actually a part of the runtime's behavior. So it does a whole bunch of other stuff behind the scenes, primarily the event polling, which, if you're not familiar with, it's just how Windows likes to keep track of things in the background. It's a bit of a pain, to be honest. Text, these turned out to be, they have special parameters in them. I didn't notice that till later. So print has this kind of ambiguous set of declarations in them, and I noticed that they're, like, in the command table, which is just kind of a list with, you've got a list of these things there, the name of the command, and there's some parameters after it, some data after about how many parameters it takes, and you might just have one parameter, for example, and then there's a classification for what kind of parameter that is. And because print can print an integer, a float, and a string, it has this kind of special case. Let's just say it's like an int float string type, which is okay back in the day, but now we've detached all this stuff. That's those little gotchas like that come back to haunt you. So we'll get rid of that stuff. So pressing on, let's go through a bit of stuff about in the help file or history. So, which I don't think we've really gone through before. So if you're wondering how to read this stuff, obviously it reads the top of the document is the latest changes. They generally will, there'll be a section here like fixes. These things here had some broken functionality, or they were in this case, the entire image was broken at some point. Not quite sure when that happened, but wasn't reported. So I've got some RIP test code, bit of a typo there. Translate mesh to scene, which is kind of an undocumented command, but it's been around a long time. I think we'll probably end up adding a mesh command set to PB at some time for generalized mesh support, so we can sort of just render list of triangles on when we move to OpenGL. Won't be a great culture shock. This is not one of those legacy commands that was actually running on. Sorry, that is actually running on the old runtime. It hasn't been translated across to run on the 165B or the new runtime. It's still being, if 165B, if the new runtime sees this instruction, it just exits and assumes that it's handled elsewhere. The keyboard state command had to be updated because there was, I think in older versions of PB, if you just say keyboard state and give it an array, and if the array wasn't initialized, it would do things like dimension the array for you. That behavior is no longer, and it's just kind of been hacked together to work with this environment here. So it needs a bit of an update too. And this goes back to how these arrays are passed and how they're declared in the command tables. If I change it in this build, we would have been there changing a whole bunch of other stuff. I just didn't want to do it. I just thought, well, no. They're commands that aren't used very often, so we'll get away with doing that in this build and then tackling them when we absolutely have to tackle them. So some changes there. We stripped a whole bunch of, stripped a whole section of the legacy array code from the old runtime. It's not necessary. So we're just getting rid of double up. When there was the two VMs sitting side by side, you got there's two different formats and things. And so eventually, as that old code's been replaced with the new stuff, we can get rid of all the old legacy crap. So things just get leaner and meaner. Command changes, legacy VM. Oh, okay. There's some really old commands that were added to do synchronization of the VM for different modes. They weren't documented, they were just there to help with certain sort of weird things that might happen. They were taken out. Similar reasoning, really. They have some kind of special behaviors, and I thought, well, we don't need them anymore, really. So I moved wait and timer into the date and time block, which is a command block. I'm not quite sure why it wasn't in there. This sequence here was see a whole bunch of VM execution table changes. This is where we're going through each command set and converting it to make it run on the new VM. There still needs to be more conversion done, actually, but you know, again, once they're converted, they're executed externally, and it's a well, actually, the execution of the command isn't really any faster. In some cases, it's probably slower because the executive is probably a bit too general. It needs to be sort of tightened up in certain ways. But obviously, in this session here, way back in April to May, I've gone through, you know, session by session and just reblocked all these command sets. Some of these command sets are actually multiple command sets tied into one. Like sprites is actually about 4 command sets. You know, it has sub command sets like the sprite commands, and then there's sprite functions, and there's like collisions, and there's local data and something else too. I can't think of what it is now. Same with maps. They've got the maps command sets, then they've got the levels and the collisions, and I think there's animations as well. The camera and world scene stuff. Took a while to get through that. All the file system stuff. It's pretty tedious work. It's not actually much fun. It's not the kind of, you know, you kind of reblocking stuff, going back, checking that things work. Occasionally you find stuff that doesn't work, and a lot of the real grunt work for this that's made this possible was done when we wrote PlayBASIC to DLL. So pressing on, we've got more legacy junk that was ripped from the VM. We've got some replacements for some problematic commands that used to be, like wait key was like a special VM mode, for example, and they had to be changed to wait. Now they're just normal commands and actually polling events internally. Probably need some changes in the future, but for now it works okay. Back in older revisions, we've got some the reblock the 2D commands. This is stuff like, you know, dots and lines and boxes and all that kind of stuff, which had some weird blocking in there for. Initially, I couldn't work it out, but there was a bit of a trick that was going on. Of course, there's always a trick. You know, some weird optimization you made, you know, years ago that all of a sudden makes no sense. It's just the way it goes. So we've got all these other command sets here that were reblocked as well. The RGB blocks, the ink and pen blocks, the bank controls, music and sound, shapes, math collision, surface control, images and image functions. We've moved the DLL command set into the new VM, which required a bit of rewriting. The new VM has a new application structure, and these other things need to access back into there, and you know, it turns out to be a bit of a pain. But the new structure is much more centralized, so all the data lives near each other, and can be accessed much quicker. So it actually caches on your processor much better than what the older one. So some of the gains we get in performance actually just come from your CPU caching the data better. Sounds weird, but that's just how it actually works. Yeah, so this is the new app structure. Assume C-like structures are. Oh, okay, so the call DLLs do some weird stuff. If you pass a PB structure and want to call an external DLL, that if your structure has strings in it, then it needs to convert those strings into something that external DLLs can understand, because internally PB doesn't use Windows-based strings. It doesn't need to. So pressing on further ago. So back in January we were doing some bit of changes, obviously. So read tape. Okay, read field output. This is the behavior that makes the runtime pop an error if the field doesn't exist. I'm thinking. I think Steve spotted that A10 didn't work properly. Going back further, string opt. I'm quite sure what that one's referring to now. Strings have internal tables, and the tables expand over time and contract. Get array status wasn't returning. Handle, delete array was missing, obviously. Sometimes things are missing because I was going to add them to the new runtime and then didn't, and then I probably took out the fallback support for it in the old runtime, so things, they would just not exist all of a sudden, You can do array copies, stuff like that. So there's a fair bit of bits that's changed, but most of the real work happened during the 165 revision, where we really wrote the core guts of the new app format, the new instruction set, built in the support for all this stuff. So a lot of our the real work was done in 165. 165B is just the getting the vast majority of it running on that new runtime, so you can get much better performance. Like if you do something like this now, I don't know, have a loop or something like that, and you've got some bank of some size or something. Sorry about the poor example. You want to poke a byte into a bank, and this is my bank. This thing here, and I don't know, 255. You want to fill it in with. So a loop like this runs entirely on the new VM side. Has done for a while, given that the banks were converted over, a while ago. But so would something, like running through a bunch of sprites or doing those kind of things, or an image, for example. Okay, so 165B has a whole bunch of new bits and pieces in it, and it doesn't mean that it's perfect. I know that there's some differences in behavior. The classic one is the type stuff. You've got, if I have a type, let's try and make something, status field or something. My object. Alright, so we've got, let's say we run through here, and what you'll find in some old examples is code that does stuff like this. We might run through part of our items in the array, and we might do something like stuff loop.status. If this equals true, then this thing exists. Well, if you look at this code closely, it won't. This can never exist. if nothing's been allocated in that time, and we try and read a field from this structure, it's going to understand how types work. You've got the array. The array is just this. In this case, it's 100 slots up here. We'll make that 10 slots to make it a bit easier to understand. So in each slot, you've got this kind of so in index 0, you've got this cell and it's got a number in it. Go down. And these are the indexes on the left. 8. Now, because arrays have exclusive rules in ranges, you end up with 0 to 10 when you're dimension something. So if this side here is the index of the data, and this is the contents of that cell representation, when we dimension stuff, it's empty. To make that just go there to 10. So when we read stuff here, we get a 0. At positions at index 0, we get 0. And then so what we're really saying is we're asking the runtime to go, okay, at position 0, at address 0, we'll call that, plus the offset of field status, well, we're saying read memory at address 0 plus the offset of field status, and then compare it with true. If this address here is 0, you're trying to read memory that's not allocated yet. In old versions of PB, it actually lets you get away with this. So over the time, I've been guilty of this as well. When we read stuff here, there's no structure allocated into this cell, so there's nothing there. So this should return a 0 and fail. If I had a bit of code down here that said, stuff, say position 1 equals new my object, then the array contents now has a structure, a newly allocated structure in it. Here you've got this. It'll be just an integer value, but it's actually some non-zero value. It might be 647, and that's the handle of the type structure that was allocated for you. So if we tried to read that firstly from 1 to 10, the first time through we would get it would read from the array index here, and we'd get a handle 760, and then we go, oh yeah, I know it. I've got a legal type handle. It would find the address of that type, and then that structure in memory, and then add on the offset, read that bit of memory, and return the value, and then compare it with true. So that's perfectly okay. The next time through, if loop was 2, nothing is allocated. Position 2, it would read the type handle, get 0, and go, hang on, this is an illegal. Trying to access memory you don't own. Yeah, just really rambling today. Okay, so long story short, 165B has this behavior. It'll trap this behavior and spit out a runtime error, whereas old versions don't. So you'll probably find bits of code around that it doesn't like. The way to get past this, if you don't understand all this kind of stuff, is that you don't try and access a field from that structure. You ask the array, is there some handle at this position? We can read this from the structure and we'll get back either a 0 or some non-zero value. What the value is doesn't matter. And when you rerun your application, these values will always be different. You know, the handle represents a chunk of memory inside the runtime. And we use handles because they're kind of safer. We can actually do runtime checks to see what kind of handle that is. Make sure you're not addressing memory that's currently died or at some other point. Which if you use a pointer, you're pretty well you're going to make those mistakes. The onus is on the coder to make sure that they get that stuff perfectly right every time. It does make some of those things a little bit slower, but it's the price you pay. So anyway, what you should do is you should have something like this. So this would loop through, and it would read the handle from here, and anything that's 0 would never be executed. It would just skip over this to the end. So it would just skip over all the ones that don't have any types allocated in it, and then the one that did, which is in this case at position 1, as we've done up here, we would have stuff equals what I call it status, some value true. This expression here would go, we could go print object still getting used to this keyboard. Yay! So we print a message that this object exists. Now, this is good for if you want to write code that you want to externalize into machine code at some later point, because in the PB to DLL translated code, it doesn't have this automatic safety checking in it. It just assumes that this stuff exists, and if you don't, you'll get crashes. I think what we'll do though is we'll probably revert back to its normal behavior in the next build. But just make sure you're aware of that stuff for the time being. So, a lot of ramble there, I'm sorry about that. A lot more ramble than I thought it was going to be. Hopefully you picked up some insight into what's in this build. Hopefully you have a bit of a mess around with it, and you can check the performance out yourself. Like, the new runtime means better number crunching. It means you can do a lot more calculations than what you could before. In general, I find that like the standard benchmark we've been running on PB for a long time, it's got down now to 1.3 seconds it takes. It used to take 8 seconds when we first started. It gives you the kind of the scope of that's on the same computer. 164p, I think it's P4, isn't it? That one was clocking in at, well, the latest build is about twice as fast as that. So it was about 2.5 seconds. There's a second version of that test which tests arrays, and that would run at about 4 seconds on 164 revisions, and much slower and much older ones, by the way. And 165b, it chews through it in just on 2 seconds, and that's without the runtime optimization that the 164 builds have. That'll be one of the next things too, is to implement the I don't know if you've noticed or not, but there's an opt expressions command. Really, it's kind of a mode for the compiler. You can kind of flip on optimization modes, and the thing is actually optimizing your code as you write it. It tries to rewrite expressions that it knows aren't that good into other solutions that work better on the runtime, which is pretty much what all compilers are doing for you. This one actually has a mode in it that'll serialize array access, particularly types. They can do, for example, the stuff here. It could serialize this into one actual access, and the speed difference is enormous. So if your code actually falls into this kind of very sequential nature, it makes massive improvements to performance. But those aren't in 164B. That's not a part of it yet. Sorry, 165B. They'll have to be updated. The instruction set will have to be updated and to ensure all that's going to work. So I didn't want to implement it because it actually uses a lot of kind of hacks in the old version. I wanted to re-enable it, but I want to make sure it's a nice and clean solution and it actually does give us the kind of performance we're after. I would say in some of those, programs that have lots of type access or sequential type access, or lots of array field access in general, we'll probably get those to improve even better than they do now. How much, I don't know. Yes, it's a case-by-case basis, unfortunately. A lot of those they will definitely be much quicker than most of these kind of basics anyway. Alright, thanks for that, indulging me in that ramble, and I hope you picked up some new tidbits about 165B and where we are with this whole process, and I'm sorry about it taking such a long time. Yeah, I wish it could be faster. Alright, thanks, and I'll catch you next time. Bye.